Yeah, thank you so much. It's going to be more a story to tell than a pitch, but let's see how it goes. So this is the first slide, and it's like preaching to the converted. We enter the era of big science and data-intensive science, and we need to face the new challenges with new tools. Some of the tools we have seen, infrastructure-wise and software-wise, very often look like what one would call a dancing bear. You know, the dancing bear is really a terrible dancer, and the wonder isn't that the bear dances well, but that the bear dances at all. This would apply to grid computing. This would apply probably to tools where you write, C++ code on the command line. This applies to a variety of frameworks and capabilities that are extremely hard to use for the vast majority of research professionals. I reviewed hundreds of proposals for the European Commission about e-infrastructure, and that's how I met JustSec. And many of those proposals were just again and again dancing bears. And one night, some click happened in my head, and I said, probably, I should start a war against dancing bears. So I went and bought an armor from a London antiquarian, and started trying to build what could be the way to get to the next level, basically, to make scientific computing and data analysis more human, more user-friendly, to connect the dots between infrastructure and software. So on that path to glory, I met my Dulcinea, and she joined that fight against the dancing bears. And today, we have a baby, a nice, cheerful baby that weighs about 3 million lines of code we have written over the last 6 years, intensive R&D. And we are full of hope that the baby will make every single dancing bear disappear from the surface of the globe. So that's what we want. I will show you a little bit what the baby delivers. So basically, we wanted to build something that takes the compute to the data, but in the most user-friendly and effective ways. So basically, we wanted computation to be easy to run on public clouds, on private clouds, on clusters, on high-performance computing infrastructures, on Raspberry Pis to connect the Internet of Things to big data in all possible ways. So basically, we created engines, we call them the data science engines, that are based on R and Python, and that could actually connect to everything. They can connect to Mathematica, to Root, to whatever you use. They are real-time, events-driven, and they can run absolutely anywhere. We created a platform and frameworks for hyper-agile data science. Basically, the idea is to allow you to build things on top of data and computations in the most easy and effective way. Basically, in few clicks, you would create a dashboard on top of your big data and deliver it with a simple URL. We wanted you to be actually able to have access to those capabilities you use on your local desktops really anywhere. We wanted you to be able to connect to data science capabilities and tools for data processing from anywhere. Here we are talking about software convergence. We would like your Word and your spreadsheet, your Excel spreadsheets. We would like your iPad, your iPhone, whatever, to be able to remotely access capability for data processing running anywhere. The big use cases for this is, of course, online collaboration when it comes to data science. We wanted e-learning and e-research to connect and to merge in one platform. We wanted to make sharing ubiquitous. Think of Dropbox. We would like basically like a hyper Dropbox for everything related to analytics. And we wanted to make things reproducible, traceable, and reproducible. This is a diagram that shows some of the ways that we achieve the goals I have just listed. Basically, we have a portal that is like your window and your helper in order to access to any infrastructure. You come and say, these are my credentials to Amazon, these are my credentials to Google, or this is my open stack running under my table, and I would like to have access to a remote session for working with R and working with Python. That happens in a few clicks from a browser, then you take control, and then you share with anyone. So basically, you don't see any difference between Google Compute Engine or Azure or whatever infrastructure you may want to use. And sharing becomes really as easy as sharing a document on Google Docs. To make this probably more easy to see, this is how the portal looks like. Those who already used EC2 would be familiar with this idea of dashboard. And so basically, you see here that I have various resources. I have machines, I have gateways, I have engines, I have tokens. I have a workbench that allows me basically to remote control capabilities I have started on various clouds. So if I go to the workbench, I have already a session running. You see here, I have various views that are linking me to a machine I have started on Amazon. I have a console here from which I can issue commands to a variety of environments. So here I'm talking to R. I will switch and talk to Python. And I can switch again and talk to Mathematica. I can use a variety of tools like a spreadsheet embedded in the remote engine that actually can have as much memory as the engine could afford. All this actually is created with point and click. So if I need another console, basically I am going to tell the system to create a new one. Everything is programmatic. So basically R becomes not only a language for programming with data, but also a language for programming with infrastructure, with services, with components, with everything. So here I'm asking for a new console. This is because I lost the session, but let's go back. So basically, I have here my second console, and from which I'll be able to remote control that engine. In order to create a new machine, all I need to do is to go to Machines and say, OK, create for me a new one in which cloud? This could be on Google, or it could be, this is a very interesting public cloud based on OpenStack called Oro. Let me start a new machine on Amazon. Of course, I have already provisioned keys. So basically, the system acts as a broker on my behalf to do things that I couldn't do by hands because I'm not an IT geek. Here, let's call it demo XLDB2015. The system already asked Amazon for the available images compatible with ElasticR. I will take this one. It has the, R and Python. I will select a capacity. For example, it could be this machine. I can go up to a machine with 250 gig of RAM. Basically, it could be a machine that holds my database, or I can connect later to any warehouse running anywhere, basically. So let me grab this machine here, T2 medium. I will ask the system to shut it down after 2 hours. I can tell the system where's my data. So basically, I can say, this is my HDFS cluster, my HDFS data, and this is what I will be looking at. Let's go to the end and launch. So basically, here you see I have a new line that says demo XLDB, misspelled it, XLDB 2015. It's pending. It will go to starting, then to running, and then I will take control. This machine, actually, that I have started on Amazon, I could have started anywhere. I could have started from my Raspberry Pi. Everything is running here, and the memory footprint is so low that it can run anywhere. And then I can take control. You see here, real-time events coming from the machine saying, OK, now the machine is starting. And then when it goes to running, I'll be able to remote control it the way I'm remote controlling the other machine here. So basically, sharing means going here and say, OK, make this particular user here. There is a user called XLDB. The password is XLDB if you would like to connect. And this user actually is able to see the same thing as myself. I'm going to connect as XLDB from my iPad. Here we go. So in my iPad, I see that someone shared with me an engine that is running on Amazon. I will ask to get a session. Probably Latifa could do the same thing and connect. So basically, by connecting to the engine from different locations, we are starting a real-time collaboration that allow you actually to send commands and see what each other is doing. So for example, Latifa, can you for example, list the variables we have currently in the R session? So Latifa is moving the text editor. Just go to one of the consoles and list the variables. You are in Python. Can you switch to R? OK. Here we go. We have these variables. Probably, I'm going to switch to device number 1. And I will get rid of the 2 plots. And here, probably, you can draw an histogram of the variable x. Of course, I could do it from my iPad. So let me do it. Here we go. So I asked for the histogram of x. It says I don't have x. OK, let me see again what variables I have. I think I have a variable z, right? Or d. Let's do d. Here we go. Histogram of d. Go. So that's the histogram of d that I have just drawn from my iPad. I will probably use my iPad as well to annotate. So let me undock this one. Here we go. So now I'm seeing the histogram just in full screen, and I am going to annotate it here. So drawing something appears in every single bit. All this is interactive, but everything you have seen, every single view has been created with a command, which is an R command. I can push a button, and everything I have done from T0 till now will be an R script that would create the infrastructure, create the virtual collaborative environment, and then give me control. One final thing to conclude with is the programmability. Basically, from the R command line or the Python command line, you can run machines on any infrastructure, connect to them, provision components and services, and share them with anyone. So all this is about usability. All this, of course, would take hours to present in details. I'll be happy to engage with you later during the discussion we will have. Thank you very much.